Okay, good evening, good afternoon, good morning from which other part of the world you are from. Today we have Mr. Manoj Kumar with us. He needs no introduction for the Indian audience, but still, I would introduce, it's my pleasure to introduce him. Mr. Manoj Kumar is a geologist currently associated with NHAI in design and DPR cell. New Delhi. He has over 22 years of experience in underground and infrastructure projects. His expertise covers hydro, metro, railway, and road tunnels, specializing in surface geological mapping, geotechnical investigations, and instrumentation and monitoring. He has worked in complex geological conditions across the Himalayas, India, and Nepal, Saudi Arabia, and urban metro projects in Delhi, Mumbai, and Pune. Prior to NHAI, he worked with leading organizations including L&T, Afcons, Startup Projects, HCC, Patel Engineering, SNC Lavalin, Amberg Engineering, and Tractable India. His experience spans all project stages from PFR and DPR to tendering and construction. And he has been a regular member of TAIym as well as TAI since 2018. We welcome you, Mr. Manoj Kumar. Over to you.
Okay, thank you, Rishi. Good evening, everyone. First, I would like thanks to Tunnel Association of India and young members for giving me this opportunity to speak on the topic of geotechnical instrumentation for slope and tunnel monitoring. As nowadays, the tunnel is especially constructed in the complex Himalayan geology, where the weak rock, high overburden, squeezing and swelling ground condition, mixed phase tunneling by tunnel boring machine. Only design are not sufficient. So continuous monitoring is the backbone of the construction control and decision making. Geotechnical instrumentation is not just about the installing the sensor. It is about the understanding of the ground mass behavior and responding before the failure occur or early warning. So here I worked during my involvement in tunnel and slope project. I often see in the most critical decision not taken only basis of the drawings, GFC drawings. We have considered the monitoring data, and this webinar will define the geotechnical instrumentation from its basic knowledge and selection of the instruments and how to implement in the NATM, TVM, and for slope monitoring. So let's start to discuss. So we will cover in our presentation is introduction, objective of instrumentation, instrumentation in slope monitoring, monitoring for the embankment of soft soil, planning of instrumentation, and for especially landslide, which is common in the northeast area and now road cutting, remote sensing and automatic monitoring, selection of the instruments for tunnel, instrumentation for tunnel monitoring, instrumentation layout, array, data acquisition and processing, real-time monitoring, some case study also included for slope monitoring and tunnel, and what is the future of instrumentation, some use of the AI and machine learning in geotechnical instrumentation, and references, and finally conclusion. So first we understand what is the geotechnical instrumentation. It's a essential tool for understanding the rock mass behavior, both in soil and rock, during design, construction, and operation of tunnel. So instrumentation start from the design to operational stage. It's install the various type of the sensor monitoring devices for the different type monitoring like displacement, deformation, groundwater table monitoring, pore water pressure, vibration monitoring during the blasting works. And this instrumentation will continue till post construction also, which is mentioned in some contracts. In tunnel construction, when we use the drill and blast, the monitoring provide which help the ground response to excavation, and it's provide the support system and optimization in the support and changes in the methodology also. So instrumentation help to detect the movement trend, potential failure zone, allowing for early warning and mitigation actions. By providing the real-time monitoring data, and data-driven insights. Instrumentation minimize the construction risk, verifies design assumption, and ensure long-term performance and safety of the tunnels. So it's very useful for the safety of the any either slope protection or either tunnel, analyze of the data and basis of the prediction of the ground mass and whatever assumption we have taken during the design and correlation with the actual execution time. The engineering practice of geotechnical instrumentation is like a marriage between the capability of measuring instrument and capability of people. So both is very important. Either the people or person who is involved in the geotechnical instrumentation, its capability, its knowledge about the instrumentation, its background, and understanding of geotechnical engineering, its tools, soil and rock mass behavior, and this type of capability should this type of knowledge should require to the geotechnical instrumentation person who is involved in the monitoring. And instruments very should be the reliable and selection of the instrument is very important. And the sometimes the people choose the lowest cost of the instruments as compared to this reliability. So we should consider the reliability of the instruments, not for cost. Uh, these are the major objective of instrumentation. First is monitoring ground and structural behavior during the construction and operation phase. Second is ensure of safety of workers, because the workers work in the confined space and underground works, which is very challenging, and provide the early warning of potential failures such as slope stability or tunnel collapse. So instrument provide the it's help to provide the early warning, so we can provide the mitigation measures, any change in the support. It's also useful for the validation of the design assumption. What is the design assumption we have taken during the design and which is used for the modeling of the ground support. So some assumption taken and that can be correlate or can be optimized during the construction phase. Assisted risk assessment and management for geological hazards. Improve decision making by providing reliable field data. Track performance over time, adding in long-term maintenance and planning. Support compliance, and essential for NATM and DBM tunnel, especially in the complex geology like Himalayas. So these are the major objective for the instrumentation, which is required for slope stability and tunnel. So which type of the instrument used for the slope monitoring? These are the followings. First is bi-reflex targets. I think most of people who are attending knows are well aware of these instruments, which is very useful and provide the quick information for displacement and deformation. Crack meter, which is used for the structural monitoring of structural crack in shortcut, secant pile, micropile, any retaining structures and buildings, especially in the urban metro. Inclinometer, which is used for the horizontal and lateral displacement or movement in slope, diaphragm wall, retaining structures. Piezometer, which is used for the groundwater table and the pore water pressure. Tilt meter we use for the knowing the tilting in retaining structures or any buildings. Borehole extensometer used for the monitor of vertical deep settlement, which can be near the slope or sometimes used for from the surface of the tunnel where the shallow overburden. Load cell used for the monitoring of the load coming after the installation in anchor and rock bolts. Ground settlement marker used for the settlement monitoring near slope, retaining structures, and along the tunnel alignment, which is installed sometimes at surface to monitoring the soil settlement. And these can be monitored through total station and GPS. Instrumentation plan and section for slope monitoring. So these are the some sketch which is used in our project. Left side is this instrumentation plan where two in place inclinometer installed at left side of the portal. Actually, this portal was done in active landslide That's why this example is chosen for this instrumentation presentation. And the deep slope base material is there, continuous seepage, and during the rainfall, it's one very critical portal. So this the rigorous monitoring scheme uh, prepared for the monitoring during the construction and even after the post construction. So by reflex target piezometer for monitoring of the pore water pressure and change in the groundwater table. Load cell installed at the anchors, which is installed through the struts at vertical micropile wall. So these are the scheme for monitoring of this is the sample scheme for monitoring of landslide and slope portal. And this is the section, one cutoff section at slide or maybe a slope. Some instruments can propose for load cell in rock bolt, extensonometer for different type of the data, any settlement, optical target at different benches. So, and ground settlement marker for settlement in vertical settlement, in place inclinometer for horizontal displacement, and piezometer for change in the water table or pore water pressure. So these instruments are minimum requirement for monitoring of the slope, and some additional can be proposed after the design requirement or as per the designer. Uh, the scheme shown in previous slide. So same, this is the implementation, 3D monitoring targets at the slope. And this is the vertical slope about 15 to 20 meter high. And some strain gauge installed for the monitoring of the anchors. For slope monitoring, like in urban metro, the deep excavation for the underground metro station. So this ES 8081, the requirement for monitoring of the ground anchors, because the anchor designed for the permanent anchor and its life is 100 or 120 years. Either this used for the temporary work, but during the excavation 4 5 year, we have to monitor whatever load coming on the anchors. So here the this instrument was central whole load cell, which is strain gauge type, and used for the load coming on the bolt and tie anchors. These are the some guidelines which is mentioned in the BS 8081 for monitoring the service behavior of anchor. So how we have to monitor what will be the frequency of the monitoring. So all details you can check in this BS code. The previous slide showed this manual monitoring, but this slide shows the real-time monitoring of the slope. Is the one example of national highway where the tunnel portal slope is monitored through the real-time monitoring. And for real-time monitoring, use some tilt sensor at different benches of the slope. Because in Himalayan terrain, the deformation and this change in the rock mass or movement is very rapidly. So we require the real-time monitoring data to provide any support. So this is the example. This is the portal location where this instruments installed at different elevation and this real-time monitoring. So we can check this monitoring data either on our mobile or laptop, or there is some alarm. If there is any changing, we can receive the trigger value and any changes in the major changes in the readings. And so we can communicate with the site team to provide the mitigation measures immediately. This is because only not for the rock, the some soil slope also required for monitoring, which is mentioned in the IRC code, this SP75. Purpose of the monitoring is progress of consolidation of the soil layer beneath the embankment must be monitored. For this purpose, the following parameters are subjected. First, buildup and dissipation of pore water pressure, rate and magnitude of vertical settlement of subsoil under the applied embankment loads, horizontal spreading of the subsoil under the applied loads, in situ shear strength. So these all parameters like water pressure, settlement, all require the monitoring. Same for soft soil, the pore water pressure, in situ shear strength, vertical settlement, horizontal movement, and heave. So for all type instrument need to install during the construction stage to know the any settlement and change in the water tables. The details, the full detail or monitoring frequency and all available in this IRC code. For the road project, the selection of location of the instrument shall be governed by factors such as height of the embankment, subsoil properties over the stretch. Usually, piezometer and settlement gauge markers are installed. So, vertical settlement gauge is there, and some piezometer is there on both sides to know the any changes in the water table. Because when the groundwater change in the groundwater table, maybe due to the change in the water table, there is chances of the subsidence or there is uh, settlement. So to monitor these type of instrument is required. Especially in the northeast region, Himachal, Uttarakhand, nowadays the landslide are very common during the highway and road cutting. And some slides are active, some is old slides. So as last time some cloud was due to this heavy rain, this is very crucial or challenging for the any highway or infrastructure project. So for monitoring of the landslide also required. First, the identification of landslide to be monitored, their purpose and expected, determination type of the measurement, definition of the location and depth of the instrumentation and number of the instruments. So how much depth? Like for example, the if we have to install the in-place inclinometer, so up to which depth is required, which type of the instrument required. Development of data equation, mostly should we prefer the real-time decision as management and presentation of the data required. So these are requirement for monitoring of the landslide. These are some schematic diagram for monitoring of the landslide. So which type of instrument will use? It's given in the table. First, inclinometer for monitoring of the lateral movement, piezometer for change in the water table, in-place inclinometer for vertical settlement or horizontal displacement, central hole load soil for installation in anchor and rock bolt, overall extensonometer for monitoring of vertical settlement at different state or at different level, tilt meter, crack meter, stress meter, rain gauge. So this is the scheme for minimum instrumentation. The details is given in IRC SP 106. So for the now coming from remote sensing and automatic monitoring. So INSAR and LIDAR is satellite-based monitoring, drone surveys there, photometry and thermal imaging, wireless sensor network for real-time data collection, and IoT-based sensor. Uh, this is the how to the INSAR will pick up the data. This is the schematic diagram. What is the benefits of the INSAR monitoring? It's large area coverage, high precision, millimeter of displacement, frequent revisit, work in remote and inaccessible terrain. There is some limitation. Where is the high vegetation like in northeast area, Sikkim, Arunachal? This will not very reliable because the tree height is more than 15 or 20 years, 20 meters sometimes. The steep slope, yes, where the high steep slope or ridge is there, so there is limitation, especially in Himalayas. Less effective for very rapid or catastrophic failure and require integration with ground instrument because this basis on the satellite, so we have to correlate the data with some instrument, manual instrument like extensometer, inclinometer, ground settlement marker. So we have to correlate this data and then we can give the results. There is some case study where the INSAR monitoring done and one national highway project, the INSAR monitoring done in Udhampur Ramban Banial section. Second in landslide in Uttarakhand, Sikkim and Himachal Pradesh, and some Josimat subsidence area where the INSAR already done in 2023. Is the INSAR monitoring done for national highway project? Here is one tunnel portal is there. So this monitoring started in September 2022 and done up to 1 year, July 2023. The maximum changes in the displacement was observed is 40 mm or 4 centimeter. And near the portal it was less than 20 mm. And this INSAR monitoring done before the construction. So the project have the sufficient data where is the changes in the soil and rock mass near the portal area. So which will be useful for later or construction stage. INSAR monitoring done in Josimat area also, where the NGRI Hyderabad opinion, the Josimat 2023 subsidence is the continued dewatering phenomenon. So they have done the INSAR monitoring where this brown was the maximum or highest risk of the subsidence, where the which is affected by the deeper subsurface dewatering flow involving the 30 meter of the regolith thickness. So these zone was identified where the major subsidence occurred through the INSAR monitoring. So what next or what the future trends in INSAR monitoring? The real-time monitoring with ground-based INSAR at project site, fusion of INSAR plus UAV photometry plus LIDAR for 3D monitoring, artificial intelligence and machine learning integration for automatic landslide detection and prediction, use of cloud-based photo platform using the Google Earth Engine, ECA, Snap, INSAR processor for large-scale hazard assessment. Now come for the selection of the instrument for tunnel monitoring. This is very important for either designer who is planning for the monitoring of the tunnel. So it depends on the tunnel size and shape, depth of the cover or overburden, geological and geotechnical condition, expected ground behavior, which govern of different parameter like rock mass condition, groundwater condition, discontinuity, critical structure at surface, and the construction method and sequence. So instrument shall be proposed on basis of these all parameters. Monitoring system should be simple, reliable, and focused on critical risk. The scheme for the tunnel monitoring. Gateway wireless node and automatic total station, which is used for the real-time monitoring. Piezometer for the groundwater table or pore water pressure. Inclinometer, which can be the real-time or manual for horizontal or lateral at tunnel portal. Borehole extensometer for monitoring of the vertical slope or vertical settlement. Load cell for monitoring of the load on anchor or rock bolts. Strain gauge for monitoring of stress in primary lining. Pressure cell, acting pressure on ground and lining. So these are the schemes, tunnels. So different instrument is there for monitoring, which is ground and tunnel monitoring. Some instruments can propose for the structures which is nearby the tunnel or above the tunnel, which details in next slide. Tiltmeter for monitoring of tilting on structure. Crack meter, any crack on the shortcut tunnel segment or structures. Building settlement point, monitoring of settlement in structure. Mini prism target, especially for real-time monitoring, and Y reflex target. Ground settlement marker, payment marker, which is used for monitoring of the ground settlement and installed above the tunnel and surface. Automatic total station, which is used for 3D real-time monitoring of the structures. So these all instruments used for the monitoring of tunnel, adjacent ground, and nearby the structures. Instrument for this is the pictures of the instruments. This bi-reflex target, robotic total station, which capable for 360-degree, crack meter, digital inclinometer. This is the readout unit for the inclinometer, casing used for installation, piezometer indicator to know the depth of the water table or water pressure, tilt meter and readout units. These are other instruments like strain gauge, welded type, NPBX, road extensometer, load cell, and anchor board. These are some pics which is installed in some project. The payment marker, soil settlement marker for monitoring of settlement, inclinometer, MPBX, load cell for monitoring in struts, piezometer, load cell for monitoring of whatever the load coming on struts, which is installed in waller beam in secant pile wall. Pressure cell, both type radial and tangential. This one radial or this is tangential, or strain gauge is there for monitoring of the stress in the primary lining or short kit, which is welded, which is embedded in the short kit. Instrument for the structural monitoring, crack meter, tilt plate for monitoring and tilting. Any we can install in column, wall for of the structures for knowing the any construction effect or construction activity. Building settlement marker, bi-reflex target for monitoring of the retaining structures, any deformation and 3D monitoring, and vibration monitoring sensor for monitoring the vibration, frequency, amplitude during the blasting activity and other piling activity near the structures. So these all instruments are used for the structural monitoring. This is the one example of the railway track monitoring during the tunneling, where the TBM passes through beneath the running railway track. So this instrument near the railway track, inclinometer for monitoring of displacement. This is instruments which is usually used in the railway for monitoring of the settlement due to the tunneling. If there is settlement in the soil, and vibrating wire piezometer to know the any change of the water table. Due to change in the water table or reduce the water table, there is chances of the settlement. The example of an underground metro project. Blast monitoring for cross passage excavation. So this is the example of one railway tunnel project in Himalayan region, where the precast segment and the blasting done for the cross passage excavation, because hard strata is there, can't be done by mechanical braking. So instrument used, the vibration sensor used for monitoring of the blasting. And during the blasting, if there is any impact on the structure, the instruments like bi-reflex target installed in precast segment to know the any deformation due to the blasting effect. And some strain gauge are installed at the this steel structure or steel frame. So this is the instrumentation array or instrumentation plan for the urban tunnel, where the TBM tunneling. So mostly three type of array along the tunnel alignment. This E-type array, F-type array, and D-type array. The detail of the array, next slide. This is the tunnel alignment, downline and upline, and arrays across the tunnel alignment. And this is the zone of influence, which can be the approximately 50 meter from either side of the tunnel. And the construction influence zone may be less than, but the zone of influence is as per the settlement contour or which will be analyzed through the softwares. This is the instrumentation array for tunnel monitoring. The three type of array mainly use the type array, D type array, E type array, or F type array. D will be used for every 25 meter, type E 200 meter, and type F array is 1000 meter. So you see the in type D array, only the ground settlement marker or soil settlement marker is there above the tunnel, both this twin tunnel. Type E array instruments includes some soil settlement marker. This borehole extensometer or MPBX is there, which will be installed about 3 meter above the maybe sometimes 2 meter in hard rock, 2 meter, and if soft rock is soil, then 3 to 4 meter above the tunnel ground. And inside the tunnel, this optical target is there. So in type E array, the 3 type of instrument is there: MPBX, optical target, and next one. Type F array. Type F array very critical array. That's why this installed at 1 kilometer or 1000 meter distance, which include the inclinocoma extensometer or MPBX, optical target inside TAIym tunnel after installation of the segment. This is the ground settlement marker. Z is the depth of the center of the tunnel from the ground level. So the distance of the installation shall be calculated accordingly. So suppose it's 10 meter height from the center, then 0.25 into Z means the 2.5 meter. So we have to calculate for installation of these instruments. The one example of the urban tunnel where the tunnel constructed through the NHAI new Austrian tunneling method. So these are the common instruments which need to be installed for monitoring. These are the some array, 2 type of array: standard monitoring system and man monitoring system. So man monitoring system shall be installed at initial start of the tunnel and end of the tunnel, and one array between the tunnel. And these array are about 10 to 15 meter distance. So this is the section of the MMS array which will include these type of the instrument: multi-point borehole extensometer, 3D target, pressure cell, both radial, strain meter, rock wool load cell. So these are the instruments which need to be installed in man monitoring system. Photographs of installation of all type of instrument here. This is the load cell installed in the rock bolt. This is the radial pressure cell, strain gauge, optical target is there, and MPBX. The one planning for the instrumentation array, hilly area terrain. So same as urban tunneling, but because in urban tunneling the overburden is less, so MPBX can be installed from the surface. But in hilly terrain where the overburden is more than 100 meter, so the installation of the MPBX from inside of the tunnel. So 3 MPBX, one is ground, one in both shoulder, and these are the optical targets, and these are the frequency. First week is once per a day, second week twice in a day, and week 3 is once per week, at week 4 or once every 2 months. And this frequency can be changed on depends on the performance of the monitoring data. If there is major changes in the instruments, we have to increase the frequency also. So there should will be the some notes also in drawings. It depends on the performance of the monitoring instruments. So for monitoring of every instrument, the threshold limit or AAA value, alert, alarm, and action value is required. So we have to carefully during the monitoring, this alert, action, alarm should be in our monitoring data sheet, because we have to monitor the instruments accordingly. And when any readings are breach the alert or action level, there is some criteria which type of the mitigation measures to be taken. So for each instrument in the instrumentation monitoring scheme, the AAA value shall be there. And these are the frequency for the instruments for each type of the instruments. What is the AAA or alert action alarm level? Alert level is normally 0.5 or 50% of serviceability or design limit. So on reaching of the alert level at any location, the contractor shall immediately submit a written report to the engineer, sometimes authority engineer, sometimes PMC, project management consultant, review all total and different movement distortion and predicting further movement. But work will be continued, but we have to inform or communicate to the engineer, which is sometimes lack of interaction or communication because sometimes what happens, we hide of this type of the readings, but we should communicate to designer, communicate to construction engineer. So we should not hide this type of any readings are breached. Action level normally 0.7 or 0.8 or 70 to 80% of design limit. On reaching of the action level at any location, the contractor shall submit an updated report reviewing the movement. The report shall allow for remedial measures have been implemented and shown to the effective. So when the action level is breached, we have to mitigate or we have to change in the support system, and we have to ask to the designer to provide the scheme, or they will review the data with their design assumption. Sometimes that can be the construction fault, but we should communicate all readings. Alarm level, this is the 90 to 100% of the design limit. In case of the alarm level is likely to reach, all work shall be suspended nearby the structure, sometimes 30 meter, it depends on the contractual requirement. The instrument affected portion of the work, the contractor shall immediately implement measures as defined, any contingency or emergency plan to make the related part control the situation. This is the flow of data acquisition, processing and submission. So first we will install the, after installing the instrument, we will fix the base reading. And it can be that different for each instrument. Sometimes optical target maybe 3 days, 5 days. But in case of the MPBX or borehole extensometer, because we have to do the grouting, so sometimes it take the time for setting time. So in case of the MPBX, it can be after 7 days or 10 days. And after fixing the base reading, monitoring of all the instruments as per the frequency which is given in the drawings, check consistency or validity of the reading. If reading are high, then check consistency, then check consistency and validity of the readings, and submission of the all the result to the team, and submission for authority engineer or GC or employer. If exceed review level, confirm the validity of reading. So these are the flow chart we have to follow from installation to monitoring of the data. Data equation, which include the manual reading, sometimes a remote or real-time monitoring, sample frequency, or data recording parameters. Data processing, data entry and storage, data validation, correction and adjustment, trend analysis, threshold trigger level assessment, and then submission the report. Left side is monitoring through the this is manual monitoring by surveyor through the total station, which is installed for the optical targets. Right side is real-time monitoring, where the total robotic total station is there, and they can monitoring at fixed frequency, sometimes half an hour, 15 minutes, or if there is no change, once a day. So these are two type of monitoring: manual and real-time monitoring. This is the real-time monitoring by the optical sensor. And through the real-time monitoring, we can continue, we can fix the frequency of the monitoring, and we can continue on our desktop or PC or mobile. So we can easily access what is after the installation, what is the changes, any deformations. So through the real-time monitoring, we can get the quick data. This is the one scheme for the real-time monitoring in the urban tunneling, where the TAIym tunnel, there is two TAIym tunnel. One is upline and downline tunnel, and the instrument installed at the heritage structures, very severe critical structures. This is the robotic total station, and these are the reference prism, which is used for the autocorrect of the total station readings, and which should be the out of the zone of influence. So monitoring of the line of action should be the monitoring instrument placement is very important. All instruments should be proper visible, and it's a range up to the 1 kilometer. Sometimes if visibility is clear, then 2 kilometer. Is the robotic total station, which is installed at the high-rise structures. TBM tunneling at both sides. This is the road, and one TBM tunnel this side, left side, and one is right side. So these are the all heritage of very severe structures where the some prism target installed for monitoring of 24-hour monitoring, and the frequency was fixed to take on the data every 10 minutes or 15 minutes as per the changes in the readings. And this is the gateway. The data through from the gateway and gateway to the our through gateway the data will send the server and then getting on our PC. So this is the systematic diagram how we'll get the data to our PC. This is the sensor robotic total station, and either FTP server or some server can be provided by the agency through the wave or SIM. The data will transfer to the our PC. The monitoring system with all the instruments, either tunnel instruments, slope monitoring instruments can be connected through the real-time monitoring. So this is the SDI 12 interface, which will use for to the data transfer. There is sometimes 4-port or 6-port, so we can monitor 6 instruments, and sometimes some junction boxes there. So we can monitor all the instrument like strain gauge, pressure cell, load cell, MPBX through this real-time monitoring. The presentation of real-time monitoring. This is left side is optical target install the tunnel, and this plotting done manually. And right side is real-time monitoring. So both monitoring can be done, but should prefer the real-time monitoring, which will provide the reliable and quick data. The example of one real-time monitoring in urban area, where the monitoring instruments installed at different structures during the TBM tunnel. And this is the graph. So you see in graph the some readings are breached all the levels. So which will if we will do the real-time monitoring, then we will get the data immediately, and we can take the mitigation measures for the structures like strengthening of the structures, providing the props, and grouting in foundation, permission grouting, different type of mitigation measures we can take on time. So real-time monitoring data, especially in urban tunnel or critical structure, should be preferred. The monitoring of the tilt monitoring for different structures, real-time data we can get every hour. We can fix the monitoring. So these are the AAA value, and these are the readings. So all readings are within the limits. The format for the instruments, these are in place inclinometer formats, overall extensonometer. Now we will cover the case study. This is one case study in Himalayan Railway Tunnel. For monitoring of the primary lining, install the bireflex targets. Observation during construction, excessive deformation occurred at ground part and alarm limit were breached. What action taken? Additional support provided means the 6-meter long SN bolt, ICMC box, and monitoring done by MPVX for deformation, if any, after the support. So this was the situation. The readings were breached due to the huge deformation, and the alarm level 35, so which already crossed. So after crossing of this deformation, the instruments, the additional supports provided, like 6-meter rock bolt and grouting. The case study 2, the slope monitoring. Location was approach road to tunnel portal. Instrument used for bireflex targets. One displacement was observed more than 50 mm to 300 mm. And after movement, after displacement is wall, there was the micropile wall where the deformation occurred. For mitigation, the 9-meter long and 32 mm dia SDA installed at 1.5 meter interval. So this was the location where this is the micropile wall which was built for the portal slope support up to the portal location. So this height was proposed height was 15 meters. So after 2 meter excavation, heavy rain was there, and the mitigation, the proper support as per the GFC drawing was not provided. Means the support waller beam and anchor, and due to heavy rainfall and no support, the wall was tilted up to 300 mm, which can easily visible. But the instrument was installed for monitoring. So you see up to this location, there is no major movement because the waller beam was there and anchoring done. But where the anchoring was not done, this part was moved 300 to 350 mm. This was the situation. The displacement started at 25 June 2021, but heavy rain was there, and the movement of displacement more than 200 or 300 mm. So due to the non-support and instruments provide the reading. So that's why the instrument is important for any structure, especially in construction stage. For the mitigation measures, when this done because this road need to be up to the construction stage 5 or 7 years. So there is cladding wall provided at that location where the major 300 mm displacement was done in the wall. This is the case 3 for data interpretation geological assessment, the use of the standpipe piezometer or vibrating wire piezometer. This is the geology or tunnel for one tunnel where the from Chinese 95 to ring number 95 to 120, there was very highly weathered rock. And when the TBM entered at this location, the groundwater table was drawdown was started. And when TBM crossed at that location, and the grouting was done behind the TBM segment, and after that the groundwater table recover and as previous level. Same when the second TBM entered at this location, the groundwater table again draw down, and when TBM crossed at that location, the groundwater table was recovered. So piezometer clearly shows due to the construction effect or due to the construction activity, there is groundwater table drawdown. When the grouting done and then the groundwater table recover. So these instruments are very important for monitoring of any construction activity. Finally, now manual monitoring or real-time monitoring. Now the time of AI and machine learning in geotechnical instrumentation. So what the AI or ML can support are transforming geotechnical monitoring by enable real-time data interpretation, predictive insights, automated anomaly detection, and optimization of operational decision in challenging environment like slope and tunnel. So what is the application of AI and ML? First is data handling and pre-processing, which will detect and correct any error, noise, or incomplete sensor signal from the instruments. Real-time monitoring and pattern recognition. The machine learning algorithm identify the unusual behavior, means sudden acceleration in slope movement, unexpected deformation in tunnel, and faster the threshold-based alert. Third one is predictive modeling and forecasting. The predict short-term and long-term displacement trend in slope and tunnel structures. So AI and ML can help for the slope and tunnel monitoring for quick data and data without any error. Worldwide in some project, this is already started. This is some example where the Seattle State Route 99 tunnel in USA, the TBM AI and ML role is TBM operational data linked to the ground movement and geology characterization, type of monitoring, TBM sensor plus geotechnical instrumentation. In Europe, the some urban settlement production models, which is currently research project for ML forecasting of settlements and slope and terrain monitoring. So AI and ML already started for help to the geotechnical instrumentation for reliable data or quick data, which will help for infrastructure projects. So is that some codes? Slope or tunnel never fail without warning. Instrumentation is the language through which the ground speaks. Monitoring is how we listen. So the instrumentation will provide the early warning, but we should communicate the readings. We should identify interpretation of data. So all things should be properly. Then we can avoid this type of the failure. The instrumentation bridges the gap between design assumption and field reality, ensuring the structure adapts before the ground dictates. So these are the very useful course. These are the references used for this study, some IRC code, some international practices. This is the civil design criteria for used in the Singapore, specific for road and bridge work, MORTH guideline, geotechnical. So the conclusion, geotechnical instrumentation, which is used for the safety, stability, and performance of slope and tunnel and geological sensitive region, for monitoring of the ground behavior, integration of modern data acquisition system with real time. Thank you.
Yeah. Thank you, Manoj Kumar sir, for that insightful and informative presentation. We will now move to Q&A session. We received few questions. First is from Divik. Like, do you also perform manual validation on INSAR baseline in mountain regions? And if yes, then at what extent did you perform it?
Do you know? Yes. Yes, we have done in one highway project where the INSAR monitoring was there, and the at the tunnel portal slope, some instrument was there. So we have correlate these data. So before the construction activity, the instruments which is installed can correlate with the INSAR technology, but maybe due to the because this INSAR done before the construction only. So after the construction activity, yes, there is some deformation or displacement was there. So if we continue this INSAR technology, INSAR monitoring during the construction activity, yes, we can correlate in proper way. But unfortunately, at that project, which is shown in this presentation, the monitoring was done 1 year before the excavation, and the construction activity started after 2-3 month of this when this monitoring was done. INSAR was closed. But yes, we can correlate with it.
Yeah, sure. Thank you. The next question is
because
from
this reliability is very good because it's so up to 10 mm, 5 mm, and 2 mm displacement can measure.
Okay. Yeah. Moving to next question. Next question is from Vakas. Sir, could you please explain the working principle of borehole stress meter and how it measures in situ stress?
Overall stress meter I have not used, but for in situ stress, yes, hydrofracture test is there prior to the construction activity, which is used for the design. But this borehole stress meter, yes, I have not used. Hydrofracture test done for which is used for the horizontal stress.
Okay. The next question is from Ritesh. How does the monitoring strategy change for tunnel excavation through mixed ground geology compared to tunnel constructed in entirely in soil? He wanted to know about the
Yes.
monitoring strategy into
Yes, for both. Yes, monitoring strategy shall be for like hard rock and mixed ground and soil is different. And for soil, different type of instrument needed. And for the mixed ground condition, yes, different type of. For the mixed ground condition, suppose if there is soil, then we can in urban tunneling we can use the inclinocom extensometer, which will the reliable data. If the mixed ground condition means initially soil, then highly weathered rock, and then hard rock, then MPBX, yeah, multi-point borehole extensometer or inclinometer can be used. So for first we need to study the ground or lithology. We have to model all type of the ground. Then we have to select the monitoring instruments and the frequent AAA value or design limits also change for soil and different strata, because if there is soil, there are chances of more settlement as compared to the mixed ground condition where the hard rock and soft rock is there. So yes, it depends on the model, the what is the predicted ground settlement, and it depends on the nearby structures also. So, and we have to check the settlement contour, where is the effect of this construction activity. So all things need to be analyzed during the design, and then we can propose the instrument accordingly.
Yeah. The next question is from Lorenzo. He's from Brazil and he has some analysis results with him. He mentioned his FEM analysis predict very small displacement for metro station shaft intersection, which resulted in very low threshold values. So he's concerned about this low limit, which may lead frequent alarm triggers due to these minor movements. So what is the potential like causing unnecessary work stop, which causes unnecessary work stoppage? So in your experience, how should this threshold value should be defined for such cases? And what should be the minimum absolute limits for the same?
Yes, for this FEM analysis, the design parameter, which is coming from the geotechnical investigation data, it depends on reliability of the data and which type of parameter. Sometimes the use the lower value, sometimes higher side value. So for design, this geotechnical parameter is very important to analyze. On basis of that, we analyze the how much settlement is there for either in diaphragm wall, either in station area for tunnel zone of influence. So sometimes we consider mostly in as per experience the AAA value as higher side, but sometimes we observe the readings were crossed either due to the construction activity not followed as per the sequence, drawings are not followed. So the several parameters are responsible for this, and this instrument noise baseline trends.
I hope he
Yes.
got his answer. The next one is from Nikhil. Can we use a triaxial acceleration transducers over railway track? And if yes, then if a tunnel passing beneath it at the time of blasting, can we use the triaxial accelerator transducers as an instrumentation?
Can we use a triaxial axle transmitter over railway track if the tunnel is passing beneath at the time of blast? Yes, but if the railway tunnel is running railway track, then we can't monitor. We have to permit the railway authority. Yes, during the blasting, we can above the tunnel, we can monitor, because there is some, if the railway track is there, maybe overburden 15 meter, 20 meter. So like in urban monitoring, urban tunnel, like TAIym monitoring, at the road, same we can monitor at the railway track also. Because we have done
Okay.
some underpass and flyover, this type of monitoring. And some railway, because railway track also, yes, we can monitor through this vibro sensor or seismograph. Or maybe real-time monitoring can be done. Because nowadays the vibration monitoring can be done real time.
Yeah. The next one is from Moin. Sometimes instruments get damaged during construction phase. How to set base reading again once instrument is replaced, since it is hard to get stable reading?
Yes, the which type of instrument like optical targets, yes, we have to calculate again the deformation at same level, because that suppose when you install the instrument, then maybe readings was 10 mm or 20 mm. When the instruments were damaged, then you can't start from the zero deformation. You have to calculate which the reading was last time noted. Then you have to calculate the resultant deformation or any settlement. It depends on the instruments. Then we have to calculate the error or and that reading should be the base reading that time. Then we have to monitor. We can't start from the zero level.
Yeah. So one question from my side. Could you please give a brief idea on time-dependent deformation like creep monitoring to access the long-term stability in tunnels or slopes, including the monitoring duration that we should get, and what are the instruments that are more dominant to this creep monitoring, and also share your experience over interpreting such data.
For the monitoring, if we say in the tunnel monitoring, the quick and reliable data through these optical targets, and we should monitor through the real-time monitoring, which will provide the reliable data. Because when we plot the manual and monitoring data, the sometimes error by the survey team plus minus something, but if we monitor the real-time monitoring, then we can monitoring the reading per day, what is the displacement what is the displacement hourly basis or day basis, so that will be more reliable. So real-time monitoring for each instrument, either special monitoring instrument like pressure cell, load cell, that can be monitored for the primary lining, but the quick information can get through this bireflex target or optical target through real time.
Yeah. The last question from John. There are a few several questions, but yeah, I will share it to on Gmail. Then you can directly answer them.
Okay.
So one last from John. What factors are considered to determine the frequency of ATS measurements when monitoring settlements?
But frequency, initially you can fix again.
Go ahead. Go ahead.
Can
Sorry.
you speak again?
Okay.
Can we continue?
Yeah, go ahead.
So frequency depends on if we do the manual monitoring through ATS, it's the sometimes once a day or twice of the day. But the if you are using the real time monitoring, you can fix every hour. So if there is changes in the reading, major changes in the reading, you can reduce the frequency. In real time monitoring, we have the flexibility to fix the reading, because when we fix the reading means every minute, then data will be more, and that will be the more. Then we have to analyze. It will take the time. So initially, we can real time monitoring 30 minutes to 1 hour, but for manual monitoring, yes, once a day or twice of the day.
And what are the factors that we should consider?
It depends on the means ground monitoring or structure monitoring.
Um, mm,
Because both the AAA value, this alert alarm action will be different, and the consideration or the design will be different. For structure monitoring, some limits is there, but ground monitoring is different limits.
I believe he is mentioning about the ground monitoring.
Okay.
He mentioned
So for
about
ground
the
monitoring,
settlements.
for settlement, yes, settlement marker is there, not optical targets or payment settlement markers. So we can monitor twice of the day or once a day. But if there is major changes, yes, we have to monitor. We have to increase the frequency at maybe four times of the day. As a Mumbai Metro, we have very critical structures or the ground. So 4 times or 5 times of the day we have to monitor near the cut right. So it depends on the structure, ground, and type of the construction methodology.
Yeah. Thank you so much, Manoj Kumar sir. I believe everyone's question is done. There are few questions are pending. So I will take one of the question and then we will end the session. One is from Mahato. He has 3 questions. On which retaining structures are tiltmeter installed? Then what is allowable tilting limit on these retaining structures, and how it validated and cross-checked with other instruments?
For retaining structures like diaphragm wall, yeah, either a micropile wall, we can install this tilt plate or tilt meter, and we should correlate with other instrument also which is installed, like if diaphragm wall or micropile this pile wall is there, or behind the wall is there in place inclinometer or inclinometer, or optical target is there. So we should correlate the data with other instrument also. Sometimes we can't believe on one readings. So when the designer proposed these instruments, it's the combination of the instrument. Like for tunnel, they proposed a lot of instrument like rock boulder cell, pressure cell, strain gauge. If some one data is giving the erratic reading, we should correlate or check with the other instrument also. So we should correlate if the retaining structure there, then optical target should be there, and inclinometer is there. So if the one reading will give the wrong results, then we should consider other readings.
Yeah. Thank you so much, Manoj Kumar sir, for an excellent session filled with valuable insights and practical takeaways.
Thank
On
you.
behalf of TAIym, yeah, thank you so much. So on behalf of TAIym, I would like to extend our sincere thank to all participants
If some
for
question
joining
pending,
us
you
today.
can write me mail, so I will answer.
Yeah.
Okay.
Yeah, I will give share your email ID with the TAIym
Yes.
group,
Yes.
so they can directly approach to you, or we can
Yes. We can
also share the
contact through
question.
my mobile. I am always available. Okay.
Yeah, thank you so much, all. Like before we conclude, I would like to remind everyone stay connected to TAIym through our social media platform and website for updates and upcoming webinars and events. So our next session will be announced shortly, and we look forward to your continued participations. Thank you once again, and have a great evening ahead.